Hello, welcome to this video. In this video, we are going to talk about features of heterogeneous catalysis or features or characteristics of solid catalysts. Along with this, we will also discuss zeolites, a solid catalyst. Its special features we will see. Now, coming back to characteristics of solid catalysts in general, the three characteristics are activity, selectivity, and specificity. We will take one by one. By activity, we mean its capacity to increase the rate of a reaction. Sometimes the reaction rate may be increased 10 raised to 10 times the original rate. For example, hydrogen reacts with oxygen to produce water. This reaction takes place in the presence of platinum. In the presence of platinum, this reaction takes place with explosive violence. This reaction can take place only in the presence of platinum. In the absence of platinum, this hydrogen and oxygen can be stored as such. They do not undergo reaction. So that is what we mean by activity. Its capacity to increase the rate of a reaction. This activity depends on the extent of chemisorption. Extent of chemisorption. Greater the chemisorption, greater will be its activity. The second one is selectivity. Selectivity. The same reactants may be made to give different products by selecting suitable catalysts. Let us see one example. The reactants are carbon monoxide and hydrogen. This is a gas, this also is a gas. It reacts in the presence of copper as the catalyst to give an aldehyde, HCHO. This is methanol. There is only one carbon atom. The same reactants react in the presence of copper, zinc oxide, and chromium 3 oxide to give an alcohol, methanol. It is an alcohol. Again, carbon monoxide reacts with hydrogen in the presence of nickel to give methane and water. Methane and water. So, in this property we see the same reactants, but the presence of different catalysts directs the reaction in different path and the products obtained are different. So, by selecting a suitable catalyst, the same reactant can be made to give different products. So, this is one example of selectivity. Another example. This is ethane. There are 3 bonds here. Reacts with hydrogen. In the presence of platinum. And the product is CH3, CH3. That is C2H6 This is ethane. The same reactant reacts with hydrogen in the presence of Linder's catalyst to produce CH2 ethene. The substance is ethene. Linder's catalyst is a mixture of palladium, barium sulfate and quinoline. So I have given two examples here for selectivity. The other property, the third property is specificity. Specificity. By specificity, we mean that its action, the catalyst action, is very specific. A substance which acts as a catalyst in one reaction cannot act as a catalyst in another reaction. That is, in this reaction, the same example can be taken here also. In this reaction, carbon monoxide reacting with hydrogen in the presence of copper, the product is an aldehyde. Whereas with another catalyst, nickel, the products are methane and water. So these catalysts are very specific, which facilitates one reaction cannot facilitate another reaction. That is what we mean by specificity. So these are the three characteristics of solid catalyst. Now we will see zeolites. Zeolites are special type of catalysts. They are called shape selective catalysts. Their general chemical formula may be written like this: M x by N AlO2 x times SiO2 y times with said number of water molecules. These water molecules are called water of hydration. Why this is called selective catalyst? When this compound is formed, the compound is formed with a definite shape. Honeycomb-like spaces develop there. Cage-like cavities. These cavities are micropores. So it is called microporous. The zeolites are called microporous because the honeycomb or the cage-like pores that develop are very, very small in size, of the range picometer. So small. When they are used as catalysts, the reactants which fall into the size of these micropores only can adsorb to the surface. The micropore size is not same. Different zeolites have different sizes. But anyway, they are of the range picometer. Sodium aluminosilicate. Sodium aluminosilicate. Zeolites are aluminosilicates with one metal. So, sodium aluminosilicate can be taken as an example. It can adsorb long straight chain hydrocarbons. They cannot adsorb branched hydrocarbons or aromatic hydrocarbons because of the size of the micropores. That is why they are called shape selective catalysts. we will see one or two uses of zeolites. Petrochemical industries use zeolites. One example is alcohol. Can be converted to hydrocarbons by ZSM5. What is the full form? Zeolite sieve of molecular porosity 5. Zeolite sieve of molecular porosity 5. This special type of zeolite can perform this reaction. Another common use is in ion exchange process for softening hard water. Hard water can be softened by using certain special type of zeolites. These are the uses. I hope you were able to follow. This portion is a bit important for the examination. Questions may be asked on activity, selectivity, specificity. You may be asked to differentiate these three features. A small question may also come from zeolite. Why they are called shape selective catalysts. By the way, in this process, the zeolite that is used is hydrated one. In some other cases, when it is used as catalyst, the zeolites are heated first in order to remove water. The space occupied by water is used by the reactants for adsorption. Water remains in the micropores. When it is heated, it escapes. I hope you will be able to answer the questions based on these points. Thank you. In the next video, we will talk about enzymes. Enzymes are catalysts in biological systems.